flight, and local activities and everything else into one portal, and also get itineraries at a unified place. So this is my project. So before I go deep dive, let me just give a quick overview what I'll be covering in this presentation. So I'll be starting with what problem we were facing, and the motivation, and some research works that have been done earlier, and the gaps that there were, and then few features, and then we'll go to the approach, the how the system is working, and then design, data collection, data analysis, result conclusions, future work, and then some question and answers. So I'll start with the problem statement. So as you can see in the diagram that, whenever we have to book a, a travel, whenever we have to plan some travel, we have to juggle between multiple apps, which causes confusion and wasted time. So like for hotel booking, we have to go to booking.com. For flights, we have to go to Skyscanner, and for local activities, we have to go to TripAdvisor and so on. So which requires a high manual effort. So hence users spend hours researching and organizing trips. And also there is a low personalization. So there are platforms, but they offer generic one size fits all suggestions, and hence we have few research gap here. So we don't have any adaptive end to end personalized itineraries. So hence we have isolated trip parts. We don't have a unified one. So hence we have a AI system now that can coordinate the full journey. So let me come to the motivation. So we know that travel is a multi-billion dollar digitally growing industry. If we look at some of the fastest growing, or the portals like Airbnb, which has been using millions of users, so it's a multi-billion dollar industry. So the pain point is that the current tool focus only on bookings, not smart planning, and hence here lies an opportunity where user wants personalized time saving solutions. So hence recognizing the potential of AI, which can intelligently coordinate trips and enhance travel experiences. So the goal is to have an AI driven, adaptive, sequentially coherent itineraries. So um, so so we have seen that the travel planning has evolved from static rules to machine learning, and then where we had personalization, but they lack adaptability. Then we had deep learning, which was able to give us dynamic itineraries, but that required high computations to train the models. So hence we are moving to Gen AI and the AI agents now. So these are some of the studies that have been done over the years. And so here, we have TripMate, which is built over these studies, which is a LLM-based reasoning agent with specialized modules and context-aware personalization. So which will be fully adaptive, and users-centered itineraries would be there. So it also uses a conversational interface. So to generate a fully adaptive user-centered itineraries. So the current features here are highlighted in green, and the future scope that we can have are highlighted in purple. So the current ones we have are like the top stays recommender, top destination recommender, and then flight planner, and activities and experience planner. So and at the central we have the trip planner agent, which manages all. So how the system works here is that there is a single trip planner agent, which is which integrates all the modules into coherent adaptive itineraries, and which uses LLM and via LangChain orchestration. So the output that we get through this one is that it aggregates output from all the modules, reason over constraints, and ensure itinerary coherence plus explainability. So the first module that we have is top destination recommender, which recommends best destination, and it uses Grok LLM plus also machine learning based collaborative filtering. So the data source for the first recommender is Kaggle dataset, and which ranks attraction using the collaborative filtering, plus using the LM contextual reasoning for budget, trip purpose, and season. So the second recommender that we have is Stay, which uses the data source for which is Amadeus Hotels API, which what it does is that it recommends hotels considering budget, location, and predicted price demand trends. Then the next one we have is Flight Planner, which also uses Amadeus Flight API to fetch the real time flight details, and which optimizes timing, cost, and availability. And the last one that we have is Activity Planner, which uses data source as Google Places API and suggests activities based on destination, budget, and cost trends. So, so here's a design that we have. I have that I have used to implement this project. So, firstly, there's a user, in a natural language that talks to the chat interface. It says like, I have to plan a trip to Bali, let's say for 5 days. He gives the days. So there's a so this chat interface also asks the user for for information so that it can personalize it. So the user will tell like these are the trip should be like $100 per day, and then it should have this kind of food, like I want vegetarian food. So all these information will be collected from the user once he tells that I this is my destination where I intend to go. So there'll be a so next at the next level we have a trip planner agent, which is the brain of all the this system. So it consists of LLM, which understand the user intent. So once the user gives its input, so the LLM understands the intention of the user, and then it gives this intent to the LangChain, which is a React framework, and its task is to find out based on the intent, give assign the work to the different recommenders, and then once the recommendations are back from the recommenders from different services, LLM understands what all he has got, and then it prepares the itinerary through it. So once we have the itinerary, so the user can store that itinerary in database. So here I'm using MongoDB, and then also once the user have prepared and is logged out of the system, then user can come back again and visit the itineraries that he has prepared over the time. So this is about the design that I've implemented. So the coming to the data collection. So we have, as I've talked, that there are four recommenders and then different data sets that I've been using. For the first one, I'm using from Kaggle, and for the other three, I'm using different APIs. So this is a data set overview, that how I've collected the data and how I have, what each data is giving me here. Okay, so this was the data analysis that has been done. So it shows that the European and Asian cities, they dominate travel, like the Paris being the highest, and others Tokyo and Bangkok being the second highest, and most trips are 7 to 8 days. So recommendations align with this pattern. So the next analysis that has been done over the stays, so which shows that the hotel leads by 55%, followed by Airbnb, and then the related technologies. So the for backend, I've used Python, Flask plus Fast APIs, and then so we know that the agent that been using is Trip Planner agent, which is a single agent LLM orchestration, managing reasoning, planning, and tool usage. So the LLM that I've been using is Grok. So the database is MongoDB for storing trips, itineraries, and user data. So the external APIs that I'll be using, and then the for front end I'm using React and a real-time chat interface. So coming to the result, so if I talk about that, AI trip orchestration. So LangChain React plus Grok LLM with 5 tools for smart conversational context aware planning. So the data is we have a verified data. So activities and flights, they use live Google Places and Amadeus data for reliable ratings, prices, and availability. So the next is the data management. So MongoDB stores the profiles and then preferences, itineraries, uh, um, in it. And then we have optimized response. So we have Grok LLM and LangChain. They deliver real-time responses which are within 5 to 15 seconds. And then engagement features. We have a conversational interface here, and then we have different itinerary cards. So there are model previews, and then there are icons, and then good UX. Then we have real-time integration as well with the live APIs with error handling, rate limiting, and fallback, which ensures accurate, up-to-date travel data. So coming to the conclusion, so AI travel planning. So we have LangChain React plus Grok LLM with 5 tools for, as we have already discussed. So as for this, we get an enhanced journey where AI travel planning replaces manual effort with modals, saving and authentication and response design. Um, yeah, I think all these we have already discussed. So the future work now comes here about that this is a web app. So moving it to a mobile app support can be one of the future scope. So additional modules include weather alerts, budget and expense planner, notification and flight, and we have a future. We can convert it into agents, which can also talk to each other in the future. So we have a better functionalities. Um, yeah. So these are the references that I have used to build my research and my project. So shall I go to the demo or we have question and answer first?
Um, Neha, you have 5 minutes pending, so we have to cover the demo plus Q&A in the next 5 minutes.
Mm, okay. So let me go through the demo. So this is the website which has like few options that we can start planning now, which starts with the start planning now option. And then we have the trending destinations here. So these are the top 12 destinations that we have filtered using machine learning. So these are the options. Either I can select from these if I want to plan from these, or I can just go to trap start planning now. So let's say I choose one of the popular destination, or let's say Thailand. So I go to Thailand and just enter. So it gives me that it's a great choice. And but it asks, as a next step, it asks that where are you going from. Let's say I can select from the drop down and I can type. So drop down and is basically given so that the user can don't have to type. So it becomes yeah. So so that user can quickly select from the drop down. So next would be like it will ask for the travel dates. So it will ask like when do you want to start. Like let's say I want to start on 13th, and then the end date is, let's say, 4 days. So it goes and let's say it selects confirm dates. So the next question that it's going to ask is like how many how much is your budget. Let's say it selects 100 uh, per day. And then it asks for the activities and experiences that you are interested in. Let's say I select food or shopping, nightlife, and then I select this. So it will ask for whom you will be traveling with. So so that it can suggest the right activities. Let's say I select with partner. And it also asks for any dietary preferences that I have. Like let's say I select vegetarian, and then it will takes some time to produce the data. So it selects, like, it gives me information that I am going from Bangkok, from Goa to Bangkok, and the dates are from December 12th to 16. And so it also gives the link, because it's we have time specific, so I cannot go and implement uh, on our website to book it. So it gives various websites that the user can select. And so it give uh, then it also suggests stays, different stays where a user can go and select on booking.com, go and select the hotel of their choice. These are the top ones that is it suggests. uh, and then we have different itineraries. Like, it can suggest that this is the time when you are going to arrive in Bangkok, and then you can have food at this place, and then suggest that there's a Thai vegetarian restaurant that you can go on. And similarly, it suggests for 5 days, so selecting fifth day for depart. And then it also has a save this trip option, where a user can okay, so it will show that it's going to Thailand for 5 days, 100 per dollar, and I can just go and save trip. So once I save this trip, a user can go to plan new trip either through this option. And then also it selects my trips to see what, like, there was a one that I had already added, and then user will be able to uh, view the itineraries here as well. And it can go back to home from here. So either I can select from the trending destination, or I can start a loop over from this option as well, where the user selects the destination. And then uh, yeah, yeah, I think I'm done. This is what I've implemented over time.
Yeah. Thanks, Neha. Thank you for your presentation. We're almost done with your time. We have 1 minute left for Q&A. So if anyone has
Yeah,
any questions, please feel free to ask. Yeah, I think we are good, Neha. Thank you so much for your presentation.
yeah, thank you, everyone.
So the next presenter for today is Lin Chao Kai.
Okay, let me share the screen. Uh, can you see my screen right now? Okay.
Yes, yes, we can see.
Okay. So my hello everyone. My project is RAG enhancement MCP system for experimentable resume screening. And um yeah, let me get into the next slide. This is my agenda. So this first the problem statement. So the first problem that we want to address is since nowadays we have as a recruiter we have to deal with lots of like deal with a lot of like piles of resume, and it's kind of inefficiency and data overloaded, and recruiter often need to manually review hundreds of unstructured PDF resumes, and with such as significantly increasing the hiring time and operation cost, and additionally the traditional traditional ad tracking systems have heavily on rigid keyword matching and false negative rates, where qualified candidates are overlooked due to minor semantic differences and lack of trust in AI. So it's the outputs are like prone to hallucination is because that the like what you once you trying to put a lot of a piles of PDF and put in like something like uh chat GPT is like easy to hallucinate it. And my motivation is yeah, so now it's kind of like a heavy workload for the most of the HR, and so that's why I'm trying to build something the customized systems to appropriate for the HR to boost the efficiency of doing these automatically um workload. And for the background, so as I think like most of students about graduates would know this kind of problem. And as a recruiter, you usually have to do the manual review. It's accurate because it's like matching like word by words, and it's accurate, but it's like very slow. And now it's like 2025, so we have to do something new. And that was keyword ATS as a accountable tracking system. It's scalable, but sometimes once you try to um, lots of um, data, it's kind of would be inaccurate. And the third one, generic LM, it's smart but unreliable hallucination. Yeah, just like I mentioned, sometimes you trying to put some since the meta that data's getting increased, it's gonna making LMs hallucinated. And this is my current the feature that I've done, and I will talk more details in the architecture diagram. Okay, so this is the basically my whole picture of my um uh flow chart of my whole project. So basically the recruiters will upload their PDF to uh the project, and the front end side I'm using a Streamlit. And after that, it's gonna send all the data into the MCP, and the um, it's gonna parsing the PDF and extracting the words, and then next steps is the text chunking. It's gonna chunking all the words and gonna um, also filter out the chunk the words overlap. And once it's vector embedding, it's gonna store it to the vector DB, and the database that I'm using is Chroma DB, and it's gonna store it in locally, and then it's gonna send it back to the layer UI layer and display the upload, and next gonna um to the phase two. And now recruiter can input the job descriptions and click analyzations, and it's gonna um, restore the vector DBs and back to this MCP to construct all the job descriptions and all the relevant context and to the LLM. And so far, I'm using the Gemini 8 AI Studio. And after all construction JSON reported and back to the UI layer, and this basically is the whole pictures of my project. And the language I use in Python and orchestration, I'm using a lane chain, and backup database, I'm using the Chroma data, Chroma DB, and LM interfaces use the OpenAI API, and the front end using Streamlit validation for the Pythonic is kind of like the library of the Python. And this is my data collections. And this is my data analyst. Is since the API keys gonna once you got more data put inside, it's gonna code something. So far I've just put like 27 for this project. This is my finding, and I'll show my um, demo of the project. Okay, so this is my project, and let me open the terminal. It's gonna take some time to build the interface, and now you can upload your file. And these are the fake data that the data set of the resume that I've downloaded from the Kaggle. And let's just say, uh, oops. It's probably like upload too much file. I just upload some of it. Uh, okay. I think there's some problem happened. So let's just test the my database uh for now. So now I can show like how many resume in my database so far. So now I can test the resume these 39 resume here, and that just a uh, like okay, like a plus years of software development experience. And it's gonna send all the data, all the data that I chunk and back to the LLM, and it will choose the most the relevant candidate. And since all these fake data has in their name, so I just put their uh, the IDs on the top here. So as you can see, this is the most appropriate um, candidate that relevance to this job description. And this also will show how much skills and experience and education would match, and also shows the the resume could the strengths and the weakness right here. Yeah, this is a previous report that I checked and analyzed. And the other function is I can uh, ranking analysis is means that it's gonna choose the top three. You can choose it from here, and like so I'll show like three of it, and it's gonna choose three of the best candidate of uh of these 39 um resume. It might gonna take some time to do the process, and during the processing, um, do you guys have any question?
Yeah, Chauka, when you showed the demo on Tuesday, I did notice that where you got the earlier error today did not happen. It looks like you may have made some code changes just to improve the presentation based on the feedback that I gave. That's for how I saw, because there seemed to be some temp variable or some variable that was not fully assigned based on the error message. But I did see what you did on Tuesday, so thank you.
Thank you.
Yeah, maybe one question before I drop off to the other session. I'm juggling between many of them. Did you experience any sweet spots as to where your the amount of words that you chunked really gave the best outcomes? So too much of chunking would be a problem. Too little chunking would be a problem. Did you find yourself in any specific sweet spots that you could maybe articulate over here?
Yeah, so I did try to find the most appropriate the unit that I should use, but I try to use kind of three template to test it, and seems like because all I have is like only the kind of few data, and so I change it like a 100 character amount for each of the chunking.
Mhm.
Yeah. And this kind of is like most fit my project so far.
Okay, thank you. I need to drop off and join the other session. Thank you. Please continue.
Thank you. Oh, wait.
Hello, Kai, are you done with the presentation?
Yeah. So now it's like waiting the result right now because now it's like processing so far.
Okay, just one moment. Namrata, are you the host, session chair for this
Yes, yes,
session?
Brian.
Okay, yeah, please, yeah, I'm joining. I joined the meeting while driving, so you know, uh, just make sure you keep the time. Um, manage the time and make sure that the third speaker also gets enough time, please.
Yes, yes.
How many minutes I have so far?
You have 2 minutes left.
10 minutes?
2 minutes.
2 minutes. Okay.
Hey, hi, Chow. I think we need to move on to our next presentation so that
Okay.
we could accommodate our last presenter as well.
Okay.
Yes. Thank you so much for your presentation.
Okay. Thank you, everyone.
Okay, moving on to our last presenter, Amber.
Yes, 1 second. And then how do I record again?
We are recording the session. You can just go forward with the presentation.
Okay. And then I can access the recording in Teams because I got to turn my part in.
Yeah, I'm not sure. The recording will be available, but not like as of today.
Oh, okay. All right, slideshow. All right, here we go. So my presentation is on predicting future homelessness rates with recurrent neural networks. There's two frameworks that I'm going to go over, and that are LSTMs and Elman RNNs, which is your basic RNN. So here's the agenda for today's presentation. And for the problem statement that I have is that Being homeless or unsheltered is best defined as living without a permanent form of residency, and homelessness remains a constant issue with more people becoming homeless and unsheltered per year. In fact, HUD reported that in 2024, via their annual homelessness assessment report, there were 30,000 reported homeless people living in Washington state for the year of 2024. So, and these rates are probably going to get higher because there's a lot more budget cuts to Medicaid, Medicare, and other social services to help the poor, unfortunate, and needy. So, can recurrent neural networks help predict future homelessness rates? And I did my best to come up with RNN codes that predict homelessness rates and populations that will either increase, decrease, or remain the same. And these findings should be used to talk to local governments about helping more homeless people in need. Now, for some background, I was homeless before when I was in the first grade. I'll elaborate that on a later date. But, anyways, these are some myths and truths about homelessness that you might have heard of. That homeless people don't have enough resources. That's true. Most have health conditions, physical or mental. That is true. Not all homeless people have drug habits. Some are employed and some are not. And not all homeless people are lazy, violent, or unclean. This is a myth that should be addressed later on. Anyways, for our background on the RNN, I use PyTorch for building the LSTM and the standard RNN. Your basic RNN, which is the element RNN, uses an output layer, a hidden layer, and an input layer. And all RNNs utilize some type of back propagation or forward propagation with the use of activation functions called sigmoid, hyperbolic tan or tan-H, or rectified linear units, aka ReLU. For my motivation, there's not that many homeless shelters in Washington. As far as I know, in Auburn, we have the Ray of Hope and a sundown shelter, but that can only help so many people at one time. So therefore, our models used, I used an RNN that has an LSTM layer and an LMN RNN, both fitted with linear regressions. And the key metrics measured are mean square error, mean absolute error, and the R2 score. Ideally, you want a lower mean square error and mean absolute error because that shows better accuracy and also shows that the RNN is better learning. But anyways, here's part of the methodology and approach. The raw data from HUD details the number of continuum of care programs per state. And I got all this data from HUD, the government website. HUD stands for Housing and Urban Development. It's one of the US departments that focuses on who's homeless, who's needy, who needs temporary housing, etc., etc. The demographics that I mainly focused on were overall homeless and chronically homeless individuals. I wanted to look at race, but I didn't have enough time to do that. I'll elaborate later on another slide. So I conducted a heat map that shows which socioeconomic features future homeless people might have, as well as who is more likely to be homeless, possibly. The heat maps generated from the RNN output data predicts these future features. Oh, actually, I didn't go over that. Oh well. Comparing which RNN is more likely to predict values and factors and features was what I looked at. So for literature reviews, there was a team here in Canada that looked at forecasting chronic homelessness for each client, which was pretty robust, though they only looked at one key feature. The students at the University of Albany conducted a study to determine the feasibility of helping homeless people find services, but not predict any future rates. Plus, they also used LLM and natural language processing from with KNN's nearest neighbors and random forest, as well as AdaBoost. Students from the University of Calgary and BMS College of Engineering predicted which homeless candidates were good candidates for housing programs. Again, this is with the use of a form of LLM because they use logistic regression. And then students from Mineral State University in North Dakota predicted and studying the correlations between homelessness and any crimes targeted toward them within the city of Los Angeles, California. And they used an ARMA model and LSTM to predict that. So this research fills in the gaps of determining determining overall chronically homeless individuals and who is homeless right in the near future. Chronically homeless for at least a year. So for my research, I use two RNN frameworks, LSTM and Elman RNN. And my optimizer is Adam. And we measure three metrics: mean square error, mean absolute error, and R2 score. There's no binary or dynamic classifications that were used before, and the literature talk more about determining who is chronically homeless with categorical data and less about predicting future homelessness rates. So here's the work matrix. Pre-processing the data was a challenge because HUD counted demographical data points like who's homeless and female, who's homeless and male, who's homeless and white, etc. in 2014. So before that, we had to fill in a bunch of zeros with weighted ratios. And that turned out to make the data really noisy, and the RNN just wouldn't converge that well or learn from the data well. So there's two CSV files. Finalized homelessness demographics from HUD that has the years from 2007 to 2025, and the one that has the years from when they started counting the demographic. So best positive correlations to look at here are year, overall number of homeless women, men, people that identify as transgender, all homeless races aside from Middle Eastern. For some reason, for some reason, HUD didn't count Middle Easterners for some reason until like 2024. And then this is with the parsed and truncated data, similar trends as before. And then for the metrics, believe it or not, the truncated data performed incredibly well. Like the R2 score here for the Elman RNNs was pretty efficient. A high score there, low score for the mean square error and the mean absolute error, which is good to see because that means that these two are pretty accurate. And the results, the training loss and validation loss was pretty consistent here. And then the predicted counts are from the model here. And this is a range of counts. And then also the element RNN on chronically homeless results. That graph is one of the best that I actually generated. In fact, the predicted counts and actual counts are so close to each other that this is pretty accurate, which is what we want to see. Now, homelessness is likely to either decrease by 16.7% to not very much, or it could increase by 0.9% to 13.5%. Chronically homelessness is said to decrease no matter what, and while it is ideal that this is declining, there's still homeless people that exist. So the next steps are to approach local governments. Like for me in Auburn, I try and talk to Nancy Backus, who's the mayor, about what to do with helping homeless people in need for Washington in the city of Auburn. And then for the future work, that'd be to look at which demographics are more likely to be homeless within the next few years. Like, are homeless white people going to be more common, etc., etc.? And then expand on this study with GRUs and uncoder decoder RNNs, because those two are RNN frameworks that I want to look at, but I just didn't have enough time because I had to deal with very noisy data and also to clean that up. And then lastly, I want to see how TensorFlow and Keras compare to PyTorch with handling RNNs. I didn't use TensorFlow or Keras because they're pretty finicky to import. Though I do agree and see that Keras and TensorFlow are great at, well, they're great at using machine learning techniques. And I have a bunch of key references here. So, are there any questions? Any questions anyone has?
Amber,
Ben,
this
could,
has got some very good data.
Oh, thank you.
Could it be used as a predictive model, or how could it be used? I came in a little bit late.
Well, what I did was I built an RNN. In fact, here it is right here. This was included in one of the slides.
Yeah.
Epoch loss. The training loss is consistent, and so is the validation loss, though it kind of picks up a little bit towards the end. And this is with the training and testing data right here. And this is for predicting future overall homelessness numbers. So those numbers are going to be more than the chronically homelessness numbers. And then the R2 score, if it's close to 1, then that means the RNN is dead on accurate. And
Thank you. I'll review this. We're recording these, so we'll be able to listen to them. And
sounds good.
I'll go back and see it. Thank you very much.
Sounds good. And then also there's this value, the mean absolute error and the mean square error. You want to get as close as you can to 0, making the predictions more valid. Unfortunately, I didn't get to 0, but the one on But the one RNN that I trained on, let's see, predicting overall, that's not it. Okay, where did I put it? That's LSTM. Oh dear, I don't think it's that. Nope, that's not it. Well, anyways, I was able to the lowest mean square error that I got. I highlighted it right here, 434 this with the truncated data. And it's truncated because if we look here, 2014 to 2025, and then if we go here, there's this data right here from 2007 to 2025, but these demographics right here, women, men, transgender, I had to pretty much guess using an average where I took the known values, I added these up, and then I would divide the average, find the average from these columns, and then multiply it with this value here because that's total homeless overall, and then fix the zeros. That somewhat helped with reducing the noise in the data, but it wasn't really that great because those aren't the true values. Whereas I decided to go off of these, which are the true values. And then, are there any other questions?
Yeah. So Ember, so looks like using the first of all, thank you for your presentation. And
Mhm.
so using the truncated data set, you are able to get the result with higher accuracy, right?
Yes,
Okay. Okay. We'll keep working on it. Okay.
sounds good.
Thank you.
And is that all?
Yes. Yeah. Thank you so much for your presentation, Amber.
Yep.
Yeah, I'll just stop the recording and we all can drop off.